My favorite type of problems. There are certain equations that are linear, maybe a little bit extra linear, that do not have numbers involved in them. It's like all letters. This is one of the trickier ones, and that's why one reason I like covering it. This has to do with electrical circuits resistance, where R is the resistance of the whole circuit. The circuit has two branches, R1 and R2, and this formula works out for electrical purposes. Kind of a neat little thing. But here I want to solve for R2. Now R2 is in this position right here. It's definitely not by itself. The worst thing is it's in the bottom of a fraction. So before I even start, I want to just get rid of all the fractions. I'm not even worried about what I'm solving for. Now to get rid of all the fractions, I need to multiply everything, both sides, by the common denominator. This one's easy. The common denominator is R, R1, and R2. So I'm going to multiply both sides of my equation here by those three factors. Alright, now when I multiply R, R1, R2 times 1 over R, the R's, just the R, capital R's are going to cancel. And we're going to be left with R1 times R2 is equal to, when I distribute these three factors over, the R1 factor is going to cancel. It's only going to be multiplied by 1 for what's left over. So we're just going to be left with R and R2. When I distribute to the second fraction, the R2's are going to cancel. We're going to be left with R1, R, and this factor of 1. So it'll be a positive R, R1. This is the point where you want to slow down and go back to, what am I solving for? Well, I'm solving for R2. R2 happens to be in this location and this location. You can't divide away. One rule that you really want to follow is never divide by what you're trying to solve for. But we do need to get them on the same side. So what I'm going to do is I'm going to move this one to the other side. Alright, now to move this one little piece is not very nice, but to move the entire term is actually kind of easy. We're just going to subtract it from this side. It's positive, so if I do the opposite, it becomes 0. So I'm going to subtract it from both sides, right and left. Alright, and let's see what happens. Now, we can't exactly combine these right now, so I'm just going to leave them alone and just write them next to each other. R1, R2 minus R, R2 is equal to, this becomes 0, and we're going to have R and R1 over there. Alright. Now we have the R2 that we're trying to solve for, at least on the same side of the equation. But if you look at these two terms, they have a common factor, R2. So I'm going to use the distributive property, factoring, and I'm going to pull out the R2. What's that leave me with is R1 minus R, and then the other side is just R1. Well, I pretty much have R2 by itself except for this term. Remember, the operation connecting them is multiplication, so to get rid of this factor, all I have to do is divide it across. So I'm going to divide both sides by R1 minus R. R1 minus R. And then these will become 1. They'll cancel out. You'll be left with R2 by itself, which is the whole goal, is equal to R times R1 over R1 minus R. And that's your answer.